Yeah, hello student. Good morning. Good morning, one and all. So, any one of you, can you please confirm that whether my voice is audible and screen is visible? Anyone from YouTube or from the Zoom itself? Anyone can confirm that my voice or whatever I'm speaking right now, is it audible to you? And again, let me share screen like function and ITF part 4 we are discussing today. Is it visible to you? Okay. Thank you for the confirmation. So it's all good to go. Okay, so everything is fine. So let's start. So basically, yesterday what we did was we started with the discussing the basic things regarding function. We started with the definition of function, and then we saw the various way of representing functions, and then we saw the vertical line test. If a graph is given to us, and how easily we can identify whether the given graph is representing a function or not. And the last one, that is we covered the range, domain and codomain of it. Basically this much we have did, and at the end, before ending the class, we are discussing the standard function. So we covered only two basic standard functions, that is identity functions and constant functions. Yes or no? So what that time what I told you, that basically for each function listed here, we'll see the its corresponding domain, codomain and range. Along with that, we'll see the graphs as well, the graph of these functions, and apart from that, we'll see some of these properties involved to it. So for each function, we are going to see this. Okay, in detail हम देखेंगे, so that this why we are doing this, because this will be very helpful to understand the functions, right? Because all the problem that coming in competitive exam or in board exam, there is high chances of involvement of these listed functions only. Okay, every time you will see the questions, you will get this involvement of these many listed functions. So if you know them betterly, like the domain, range, the graphs, and everything, so it will be very easy for you, right? It will be very easy for you to understand the thing. Okay, so let's start without any further delay. So identity function we saw constant. So start with the polynomial function. So basically, if you see the polynomial function, from your class 8th, 9th, you saw what is polynomial, right? So you know everything about it. So basically, it's a polynomial functions. How polynomial look like? It will look like in this form, yes or no? Generally, the polynomial functions look like this. Yes or no? Look like this, right? So basically, the polynomial function look like this: a n x to the power n plus a n minus 1. Then next is a2, a1, a0. These are the constant. These are real numbers, and they are called the coefficient of the polynomial. And or the power, you saw that variable here, that x to the power n, x to the power n minus 1. The variable is x. This is a polynomial in x. If it is in t, then we call it a polynomial in t. And the power that is n minus 1, is all these things. You can see they are non-negative integer. Please be careful that whenever we are talking about polynomial, the power of the variable must be non-negative. Perfect. So now how the polynomial function is defined, it is again the same. We are extending that polynomial in terms of function. So basically the function f r to r, the polynomial for the polynomial function, the domain is r and the codomain is r as well. And the y is equal to f of x, a n x to the power n, a n plus 1 x to the power n minus 1, and so on, as like it is a polynomial in x. For all x belongs to R, x is the domain of the function, x is the variable here, so x belongs to the domain of R. So domain of the function, and any r, it can take any r. Polynomial function can take any r. So all the power of x are non-negative integer, and a and a minus 1 of this belongs to r is called a polynomial. So polynomial function is nothing but it's a something like f of x is equal to a polynomial. Okay, whenever there is a polynomial, you know different type of polynomial, different degree of polynomial, yes or no? You have seen many varieties of polynomial, right? These are the example of some polynomial functions. Okay, these are not polynomial because since you can see x to the power minus 1, again x to the power half is there, x to the power half. What we said is that it should be non-negative integer. It should be 0, 1, 2, 3 like that. So, but here it is half. Again, in this case, it is 9x plus 1 divided by divided by x. Right? It's a you can take it to the numerator and the power will be x to the power minus 1 again. It is not a polynomial because negative integer exponent or the fractional exponent is not allowed in case of polynomial. So we are discussing polynomial function. The next is the what is degree of a polynomial. According to that, the polynomial function has been named accordingly depending upon the degree. If a function of a polynomial function f of x is a n x to the power n minus 1 x to the power n minus 1 in general look like this. So if this part is not equal to 0, okay, if a n not equal to 0, then the highest degree of this polynomial is n, yes or no? Okay, this a in the highest, this is the degree, right? This is the degree. Okay, the highest one we consider is that the highest power of the variable is called the degree. This one is the degree. Okay, so now if a n not equal to 0, this represents the degree of the polynomial. So in case of constant, right? Constant can be written as a x to the power 0. So you can see that the highest degree highest degree of the variable is 0, right? So it is called so the coefficient is a again. So it is a constant polynomial. Okay, constant polynomial function since it's a polynomial function of degree 0. Similarly, zero polynomial it's a special case. If f of x is equal to 0, then it is called a zero polynomial. ठीक है, जहाँ पे सारा coefficient, every coefficient involved in the polynomial is 0, then in that case the entire function will be 0. So it is no doubt it is a constant function, but f of x is equal to 0, we call it zero polynomial function, or simply a constant function is said. Okay. Next is the linear polynomial functions. Yeah, linear functions. Whenever we talk about linear function, that means it is a polynomial function maximum degree of 1. This will maximum degree is 1. So that is ax plus b. So please do remember this, the polynomial function, quadratic polynomial function, that is ax square plus bx plus c, because the highest degree will be 2, 1, 0, 1, 0, right? So cubic polynomial function ax cube bx square cx plus d, and say the quadratic polynomial function which will be degree 4, like that degree 5, degree 6, and so on. So majorly we are mostly you will deal with linear polynomial, quadratic polynomial, cubic polynomial, and their graphs, roots, everything. In terms of competitive exam, mostly you will see this kind of polynomial involved in it. But in general, you know how polynomial functions look like, and apart from that, you saw the domain of it, right? Okay, next. So how the basically yesterday we saw the graph of a constant function. So constant polynomial is same as the constant function. So it is always going to be a straight line parallel to x. As I told you, if it is a positive, then it will lie above x-axis. If it is negative, it will lie below the x-axis, but it is going to always be parallel. It is always going to be parallel. Okay. So next, linear function. Whenever we talk about a linear function means f of x is equal to ax plus b. This is constant function means f of x is equal to a, where a belongs to any real. Okay. So there ab also belongs to r, and a is not equal to 0. Okay. So in this case, this is always a straight line. Okay. The linear function always a straight line. If you want to draw a linear function, b can be 0, but a can't be 0. If a is equal to 0, then it will be f of x is equal to, it will become a constant polynomial rather than a linear polynomial. Linear function means it must be of degree 1. So it will always be straight line. And what is quadratic polynomial? Quadratic, if it is a quadratic function, so that is f of x is equal to ax square plus bx plus c, and abc belongs to R and A is not equal to 0. If A is equal to 0, then it will reduce to linear polynomial. So this always will be parabolic in shape. Okay, it will be parabolic in shape. Okay, so now it's audible. Hello. JNB Amatmal is audible. Can you please confirm? Oh, fine. Thank you. So, what we did so far, we saw the graph of quadratic functions का in detail हम graph वैसे 11th में सीखते हैं. We know how they look like. Basically, it will be a 6 different graph. For a greater than 0, it is always going to be upward facing parabola, and for a less than 0, it will be downward facing parabola. Okay, I will draw 3 different graphs for you right now. Okay, this is my x-axis. Okay, this is my x-axis. Think about that. Okay. So if depending upon the value of b, it will be look like this. It will be look like this. Upward facing parabola. If b is strictly greater than 0, they are having 2 roots. This will be alpha and beta. Okay. I'm talking about the graph of a quadratic function. Ax square plus bx plus, you have to remember all this. Okay, it will be very, very helpful. Even if in CBSE board also it required, in order to find the chapter, that is area under the curve, in order to find these areas. Suppose the question is asking to find this area, you have to you need to be able to draw the f of x is equal to x square plus b plane, right? Then only you will able to find the area in between from alpha to beta. So again, the second part is look like this. So going to touch the x-axis. So here, and in this is case, the one discriminant is 0. D stand for discriminant. I don't know this is d square minus 4ac. Right. The next is it will not going to touch or cut x-axis either when d is less than 0. That is no real root. You know, no real root to 2 real root, and this is equal root, right? Alpha is equal to beta. Similarly, it's the opposite of it. If a less than 0, there will be a 3 different graph look like this. It will be like this: downward facing parabola, alpha comma beta will be here. Okay, and it will be like this again. Okay, sorry, the graph is inappropriate though, look, not looking like parabola, but you can see the shape. The main agenda is to know the shape. D is equal to 0 here, and this is g greater than 0. Okay, so and the last one, that is D completely. Okay. So where D is this. So if a quadratic function is completely positive, okay, just do remember that this is the very, very important thing. This one and these 2 things. If someone says that a quadratic function is always positive, this always positive means if a graph is always positive, if any function, please do remember, for any function, if someone says that it is positive, means the graph will lie above x. If someone says that it's a negative function, that means if you draw the graph will lie below the x. So you can see that in this case, the graph entirely lies below the x-axis, right? Let's say name it as 1, 2, 3, 6 different cases, 4, 5, 6. Okay. In case 6, in the case 6, you can see that the graph is entirely below x-axis, that is negative. So I can say that my function ax square plus bx plus c is strictly less than 0 for all x belongs to R. For every real, it is negative. How it is possible? In that case, the condition should be what? A must be negative and D must be negative. Okay. Similarly, if someone asks you like a quadratic function is always positive, In that case, what should be your answer? Like b should be less than 0 and a is what? This x square plus bx plus c is strictly greater than 0 for all x belongs to. So these are the only fixed possibilities of a further quadratic equation to look like. It is parabolic in shape, and you can see that for every parabola there will be a vortex. Vortex is something that it breaks the parabola into two equal per symmetric part. You can say like this for everything, like for every graph it will work, and that point is minus b by 2a comma minus d by 4. Please do remember that this is the vortex that top this point minus b by 2 minus. So this is we are talking about the polynomial function. We saw what is polynomial function, how the graph look like, and different type of polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and okay. So these are two basic which we generally most time we have to deal with this function, that is x square. The graph will look like this, will be like this, and the graph of x cube. Okay, x cube is something like this. Okay, and this tends to infinity, tends to minus. You can see that the range of quadratic functions different from different functions. It cannot have like fixed range. You can see that for this case, the range means what? It's from 0 to infinity, right? The range of this y is equal to x square. The range is this, right? This is the range. Yes or no? Because the height of the function start from 0 and it goes up to infinity. Okay. Similarly, if you see this range, a range of, if I ask you y is equal to x cube, then in that case, what will be the range? You can see that the graph extend up to infinity, graph downwards moving towards minus infinity as well. So a range is kitna ho jayega? R, entire R. So for different function, the range is different. For same, this is a polynomial function, this is also a polynomial function. We just took the simpler version of that, okay, only x square and x cube. You can see that the difference. So like unlikely the constant function has a fixed range c, and the identity function is the entire R. But in polynomial function, it is going to be different for different functions. So we need to calculate that range in order to confirm that what the exact range. Okay. Next is rational function. It is very much linked to polynomial function. Rational function is of the form, as you know, the rational number also is of the form p by q. Yes or no? Q is not equal to 0. You know the rational number, right? The rational number is look like this. Similarly, in terms of here, in terms of p and q, p1, q are what? P and q are integer, right? Integer. So this we know from our childhood days, rational number. But what do you mean the rational function? It is almost the same, that p by q, where q is not equal to 0. But please do remember that it's mostly polynomial. So if you saw something like in the numerator, that is a polynomial, and in the denominator you saw again some polynomial of any degree. There is no restriction on the degree, that it should be like higher degree or low degree, not like that. So if such case you saw something like that, then you can easily identify this is a rational function, like f of x here, g of x is here. These are rational functions, right? Because from the numerator you can see that 3x plus 1 is a linear polynomial upon linear polynomial. Here it is a quadratic upon quadratic. No need that the degrees should be equal, right? I can write a new function h of x as 1 by x cube plus 3x square minus 5. Okay. This is also a rational function because 1 is a constant polynomial. This only thing is that it must be a polynomial. There is no restriction on degree, or always it will be numerator and denominator degree will be equal. ऐसा कुछ नहीं है, ठीक है? So that I can take any random polynomial in the numerator and any random polynomial in the denominator, irrespective of any degree and everything. Okay. So I hope you understood what is basically rational function is. Okay. So in order to find the domain of a rational function, how we generally, in order to find the domain, Okay, so we know that from one thing from the higher study from the class of like 9, 10th, we know any non-zero upon zero is not defined, right? Non-zero upon zero is not defined, is not defined. That means if a rational number is px upon q of x, okay, px upon q of x is a polynomial. If this part is 0 for any such values of x for which this is 0, then the entire function f of x would be not defined. Yes or no? If मैं कह रहा हूं क्या g of x is equal to 0. If g of x is equal to 0, then px upon for any such value of x for which q of x becomes 0, then non-zero upon 0 at that same time px will be non-zero. So non-zero upon 0 would be what? Not defined. So that means in order to find the domain of rational function, we have to delete those values of x for which the denominator, that is q of x, is 0. Okay. So for example, let's say our function f of x is 2x plus 1 divided by 3x minus 2. So if someone asks what is the domain of it, without any second thought, just make this function, this denominator as 0. So I will take it 3x minus 2 is equal to 0. I will solve it and find the value of x, that is 2 by 3. When x is equal to 2 by 3, this is not defined because the denominator becomes 0, and you can see that the numerator will be 4 by 3 plus 1, that is 7 by 3. This will become 7 by 3. If put x is equal to 3 and this becomes 0. So 7 by 3 upon 0 is not defined. Yes or no? 7 by 3 upon 0 is not defined. So that means what would be your conclusion in that case? That except 2 by 3, if you put any other value, it will going to be a non-zero number. So what the domain is set of all r but x not equal to 2 by 3. Or I can say from the set of real number, I will delete the number 2 by 3. This is my domain of it. Generally people write in short form as d and underscript करके f लिखते हैं, so that it represent the domain of it. So r minus 2 by 3. I hope this is clear. For any rational function, now you can easily find the domain of it. Okay. How will find the range of this rational function? Finding range of rational function is very much easy. You just have to write. Let's say if rational function is given to you, let's say f of x is equal to p of x upon q of x. Okay. So what we'll do is that just assume this as y. Y is equal to p of x divided by q of x. What you have to do in the very next day, you have to calculate something. You have to do some extra calculations here. Here it is y and every term of x is here. You got it. All the x terms involving terms are in the right side of it, and single y is here. What next you will do in few steps after calculating, you have to convert it as x one side and all the terms of y here. All the terms of y. So all the terms of y will be one side and all the terms of x will be one side. Okay. After doing this, I'm writing this. If we have f of x in the equation, replace with y. That I did. Solve the equation for x. Okay, that I'm doing. Solve the equation for x means you have to put x one side and all the terms of y one side. Set the denominator of the resultant equation not equal to 0 and solve it for y. So if this is something upon something, right, you will get, let's say, h of y upon g of y. You will get like this. Okay. And what you have to do, you have to find the domain of this new function. You got it? Okay. We'll see some example where you will get better clarity on it. H of y upon g of y. If g of y becomes 0, you have to find the domain of this function, right? So if this is become g of y not equal to 0, and you'll delete that y from this, and that will be the range of original function. Okay, we have to find the domain of h of y upon g of y. Okay, that we know. We just saw how to find the domain of h of y upon g of y, and that domain will give you the range of this. I'll show you, just show you right now. Okay, find the range of this. Okay. Find the range of this function. ठीक है, हम कैसे मिलेगा range? Let us replace f of x with y. ठीक है, then y will be like this. Now we'll solve it for x. How we'll do that? Simply write. I can solve it for now. Y is equal to 2x plus 1 divided by 3x minus 2. I just need to cross multiply here. 3xy minus 3y is equal to 2x plus 1. My aim is to what? To make all the x term one side and all the y term one side. So what I'll do is, so I'll take 3xy minus 2x and this will be 1 plus 3y. You got it? Now I can take x common. That is 3y minus 2 is equal to 1 plus 3y. Okay. So x will be 1 plus 3y divided by 3y minus 2. Sorry, any calculations error? 3y minus 2, 3y, 3x minus 2 by 2x plus 1, 3xy minus 2y. Oh, God, here it will be 2y, right? It will be 2y, sorry. So, again, this will be 2y. So, this will be 2y and this will be 2y. So, 1 plus 2y on 3y minus 2. We got it, something like that. If you solve, we can see the same thing. We got it here. Like x is equal to 1 plus 2y 3y minus. Okay. See the initial function. This was the given function to me. Now I converted into look like this. X is here, y one side, all the x are here, but here you can see the difference. Here is x forward. Now we have to find this function domain. This function domain would be what? R minus 2 by 3, yes or no? इतना होना चाहिए ना, r minus 2 by 3. होगा या नहीं होगा? क्योंकि इसको जीरो करोगे, 3y minus 2 को तुम जीरो करोगे तो क्या मिलेगा? r minus 2 by 3. ठीक है. Now we find the domain of this function, but ultimately what this represent the range of the original given. ठीक है. So I can conclude here that the range should be collection of all those y belongs to R, so that y not equal to 2 by 3. I can write in different way also. Like it's the simpler way of writing. R minus 2 by 3. This is your answer. I hope this is clear how to find the range and domain of a rational function. In order to find the rational function का domain निकालने के लिए क्या करना पड़ेगा? जो नीचे denominator का जो functions होगा, तो उसको क्या करेंगे? जीरो कर देंगे. कहानी खत्म. ठीक है. नीचे जीरो कर देंगे, जो x आया उसको रियल नंबर से हटा देंगे. कंफर्टेबल, फाइन. और नेक्स्ट क्या आ गया? नेक्स्ट आ गया हमारा रेंज निकालने के लिए. रेंज निकालने के लिए जो भी दिया जाएगा उसको y से अज्यूम कर लेंगे. y इक्वल टू 2x + 1 / 3x - 2. देन क्रॉस मल्टीप्लाई करके क्या करेंगे? x को एक साइड ले लेंगे और पूरे y को एक साइड ले लेंगे. ठीक है. और फिर क्या करेंगे? जो y वाला फंक्शन जो मिलेगा ना, ये नया फंक्शन, उसी का डोमेन निकाल देंगे. बट हमें पता है हम डोमेन निकाल रहे हैं, बट अल्टीमेटली क्या करेंगे कि यार उसका रेंज ही आ जाए. ठीक है, वो हमारा गिवन फंक्शन का रेंज है. ऐसे टाइप का क्वेश्चन को प्रैक्टिस करना, अच्छे खासे स्टैंडर्ड बुक में मिल जाएंगे. कोई भी प्रैक्टिस कर लो, आ जाएगा, आइडिया लग जाएगा. ठीक है. So if I ask you this question कि find the domain and range of this function, you can easily say that domain क्या हो जाएगा. देखो डिनोमिनेटर में y है, x है, x is equal to 0 को हटाना है, तो डोमेन मोस्टली क्या हो जाएगा? डोमेन ऑफ दिस फंक्शन विल बी r minus 0. रेंज बताओ. रेंज को क्या करना पड़ेगा? रेंज के लिए जल्दी xy को क्रॉस मल्टीप्लाई कर दो, x को एक साइड कर दो, y को एक साइड कर दो. करने के बाद x इन टर्म्स ऑफ y लिखना है, फिर y उस फंक्शन का डोमेन निकाल देना है. काम है ना? कितना इजी है. बस ये प्रोसेस स्टेप्स याद रखो. ठीक है. डोमेन हमने निकाल दिया. ये रेंज क्या करना पड़ेगा? 2x + 3x = y. तो मैंने xy क्रॉस मल्टीप्लाई कर दिया, 3 को एक साइड रख दिया, x - 2x आ गया, फिर x कॉमन ले लिए, फिर 3 कर दिया, x = this. तो यहाँ पे हमने पहुंच गए x = 3/1 - 2. हम इस फंक्शन का डोमेन निकालेंगे, दैट इज y not equal to 2. y not equal to 2, yes or no? y 2 पे ये 0 हो जाएगा. ठीक है, तो इस फंक्शन का डोमेन निकाल दिया, बट अल्टीमेटली आवर आंसर शुड बी रेंज इज इक्वल टू r minus 2. ठीक है, so this functions can give you everything except 2. So this function का range तो option B is correct. I hope things are very much clear to you. ठीक है, so what we studied is that we completed two functions right now, that is one is polynomial function, one is rational function. Yesterday we covered the constant functions and identity function. Now we'll jump into exponential functions, logarithmic function, right? So exponential function basically look like this. As the name suggests, you can see that there is involvement of exponent. So exponent functions mein this will be f of x is equal to a to the power x. The output, whatever the input will give, it will be like a to the power x. Here x is variable, a is fixed. Okay, a is fixed. This is called the base of it. And a should be, please do remember, a should be always positive and a should not be equal to 1. Okay, for any base for exponential function to define that base, that a to the power x, a is fixed, it is a constant, and x is going to vary. I can, in place of a, I can't take any negative number and I can take any 0 as well and any 1 also, because 1 rakhoge, so you can take any x values, it will be same as 1 only. So output is always 1, that means it is same as a constant function. So it's not going to be a different function. So f of x is a to the power x, where x is a variable and is a constant, is called the base of the function, and it should be greater than 0 and not equal to 1. So isko kehte hain exponential. Just like 2 to the power x, half to the power x, half to the power x. Yes or no? A can be half also. इसको लिख सकते हैं 2 to the power minus 1 का power x, तो 2 to the power minus x. तो ये भी हो सकता है, ऐसे दिखेगा, बट ओरिजिनल देखो x तो कोई भी रियल हो सकता है, ठीक है, x भी कोई भी रियल हो सकता है. So this is an exponential function, and e to the power x mostly we will deal with e. क्या है? e एक Euler's number है जिसका वैल्यू है 2.71828. Again it is actually 1828459045. ठीक है, so I remember this much only, so this many decimal places. तो यहाँ पे क्या हो जाएगा कि ये जो e का वैल्यू है वो भी बेस हो सकता है ना, हो सकता है कि नहीं, क्योंकि इसकी वैल्यू 2.71, तो 2.1 है, मतलब इट इज पॉजिटिव है, 1 तो नहीं है ना, तो दैट मींस ये भी बेस हो सकता है, तो ऐसे भी बेस देखने को मिलेगी. ठीक है, सो you must be familiar with the exponential function now, how it look like. ठीक है, now we'll see the graph of exponential function. ठीक है, if you see the graph of 2 to the power x, 2 to the power x, how it will look like? If I put -2, it will be something like 1/4. If you put -1, it will be something like 1/2. If you put 0, it will be 1, and if you do 1, it will be 2, and if you put 2 is 4. You can see that if you keep increasing the value of x, the value of y is also, or the function value, this is y, right? This is your y. If you keep increasing the value of y, 0, 1, 1, 1, the value is increasing, and if you keep decreasing the value of y, so that is the value of x, -1 times 0.5, and if you put -2 again, 0.25, that is again lesser than that. So ultimately what is happening, the graph is 0 times 1, 1 times 2, 2 times 4, so it will keep increasing, yes or no? And if we give negative input values, it will be going to downward direction. Okay, but it will never going to touch x-axis, because 1 by, if you write any negative number, right, so 2 to the power any negative number. Okay, so I can write it as 2 to the power any negative number. I can write 1 upon 2 to the power that positive number aa jayega, yes or no? This is like 2 to the power -1. How will write 1/2? Or 2 to the power -2, that is 2 to the power 2 positive, like this only. So ये क्या हो जाएगा टोटल, 2 to the power negative, 1 upon positive. You can see that this is a positive number, right, divided by 1. It's like anything, any bigger number you can think. Its value will be 0.000000000 10 lakh zeros or 1 crore zero, and after that there will be 1, yes or no? but practically this is not 0. Na? From the graph we can see that it will be very close to 0, but it will never going to touch the x-axis. Yes or no? So the exponential function never 0. Okay, please do remember, exponential function never touches x-axis. It will be very close to x-axis. Whenever we draw the exponential function, we'll take a gap from here. ऐसे थोड़ा छोड़ देंगे. So exactly आके match नहीं करेंगे. Okay, this will be look like this. This is for 2 to the power x. If you in the reverse way, that means here a is greater than 0. For any a greater than 0, the graph will look like this. If someone asks you, please draw the 3 to the power x graph, you can draw it like this. Sorry. 3 to the power x. It will look like the same. 0 times 1, it will be look like this. Okay. 4 to the power x, it will be look like that. Okay. 4 to the power x. All the graph will be very much similar to like this in this pattern. Okay. So and the reverse one, if you put the value a is less than 1, okay, value is less than 1. In that case, the graph will be different. Because in the negative, if you put any negative values, it will be keep increasing. If you decrease the value of x, the value of y increase. And if you increase the value of y, it will decrease. Okay, you can see, sorry, value of y, value of x increases, value of y decreases. So this is called decreasing function. The function keep decreasing, the x values you are increasing in direction, but the y values is declining. That's why the graph height is every time it is decreasing. Yes or no? Again, it will never going to touch x-axis, so it will be look like this. Okay. So for any exponential function whose base is less than 1, it is always going to be in general look like this. Okay. ये कभी touch नहीं करेगा. This is x-axis, and this is always going to be 0, okay. So we saw the overall think about the graph of exponential function, the neighbor to graph. We can see that f of x 2 to the power x is increasing, whereas g of x, this is decreasing. Yes or no? You saw it, right? So this is decreasing. Thus, the graph of exponential function f of x in general, what I can say, increases when a greater than 0 and decreases when a lies between 0 to 1. Okay. So and you can see the graph, multiple graph, 2 to the power x, 3 to the power x. And this is 1 by 2 to the power x, whereas red indicates 1 by 3 to the power x. Any number which is lies between 0 to 1, the graph is look like this, and it keep increasing if it is greater than a. And from here you can see the both the conclusions here. The domain of the exponential function is set of real number. It can take any real value. आप x की जगह पे कुछ भी real रखो चलेगा. But the range is a set of positive real number only. It will never going to be 0. आप किसी भी function को देखो, ये तो x-axis को छुएगा नहीं. And ये कहाँ जा रहा है? ये बढ़ते बढ़ते कहाँ जा रहा है? Infinity को जा रहा है. देखो 2 to the power x, 3 to the power x, all those things. And half to the power x, it is infinity. It is going to infinity. ये ग्राफ कहाँ जा रहा है? ग्राफ का हाइट देखो, ये कहाँ से कहाँ तक जा रहा है? From 0, starting from 0, it is very close to 0, but never equal to 0. So that's why it's become open here and 0 to infinity. Okay. So I hope graph of exponential function is clear to you. Next is moving to logarithmic function. So basically, logarithmic function is something like this. If let's say 2 to the power 3 is equal to 8. We know from the childhood days that 2 to the power 3 is equal to 3. This is your base, this is your exponent, this is the value. Now I can write the same thing. Okay. So if I ask you 2 to the power what is equal to 8? Your answer would be sir 3. Okay. Right. What is the number that 2 should be raised to get 8? So you will tell that sir ये 3 होता है इसका आंसर. ठीक है. That same thing को लिखने का तरीका है. I can write it as asking this question: 2 what the power that 2 should be raised to get 8. So I'll ask you. ठीक है. Log 8 to base 2 is what? Or I can say that 3. Okay. Writing this is same as 2 to the power 3 is equal to 8. I can write it log 2 to 8 is equal to 3. That means whenever there is something written here and here, you just have to ask yourself, 2 को कितना रेज करने पे 8 आएगा? तो आंसर इज 2. If I ask you log 2 to 100, sorry, log 10 to 100, तो you'll definitely tell that sir 2 होगा, क्योंकि 10 को कितने पावर रेज करने पे 100 आएगा? 10 का स्क्वायर 100 होता है. और let's say I'll write 4 to 64. तो आंसर would be dot 4 को कितने पावर रेज करने पे 64 आएगा? 4 into 4 कितना आ जाएगा? 16 into 4, 64. That is 3. Answer. So this is the how the log is. ठीक है. Log is very simple though. ठीक है. You just have to ask yourself what is that. So basically, if you see that from 2 to the power 3, 8, this thing generated, right? So this 2 is the base of exponential function, or this is the base of this become the base of log. This b. Okay, and this value x is here. Okay, and this 3 is the exponent. Okay, so the function f of x is equal to log b to x, or y is equal to log b to x, where b should be greater than 0, because where b has been taken from where? B has been taken from the base of exponential function. That's why exponential function base kya tha? B greater than 0, b not equal to 0. Sorry, b greater than 0 and b not equal to 1. So log ka base and exponential function ka base both are equal. They have the same restriction. Okay. Now you can choose a sir. One thing I noticed ki when there is an exponential function, the range is 0 to infinity. That means the y values a to the power x is equal to y. Y belongs to 0 to infinity. And whenever we write log, this 3, sorry, this 8, yes or no? This 8, right? This 8 is the value here you choose, right? So that means this 8 will always be log will only define for positive number only from 0 to infinity, right? This 8 match with this. Okay, this y 8 to the power x is equal to y. I can write 2 to the power 3 is equal to 8. This 8 is y, right? In this case, so that means whenever we define log, we should remember that this base is same as the exponential base. That's why it lies between. It should be greater than 0 and be not equal to 1. And similarly, the value for which log is defined, for which values we can't find the log value of negative number, only from greater than 0. Okay. And this exponent will be the output. Exponent can be anything, right? X can be anything. This x will be the answer, right? A to the power x. X can be any real number. That's why log value, that's 3, can be any real number. Okay. So if we define the log function, what should be the domain? Tell me, what should be the domain? What are the possible values of x? X can be only positive real number. That's why this is the logarithmic functions ka domain ho jata hai 0 to infinity. What should be the range? Sir, it can take any real value. Okay. It can take any real values, and we have two different logarithmic. If log base is e, you see the base b here. You can see the base b here. If in b can be greater than 0 and b not equal to 1, sir, I can choose b as e, because e is a positive number and its value is 2.718. So I can be a base of some log function f of x is equal to log ex. Okay. People have a tribute to that Euler's number. Okay. So they, instead of writing log 2x, they write it as ln x. Ln x means it is a logarithmic function whose base is e. Okay, its base is e. But whenever there is the base is 10, it is called common logarithmic. We generally don't write anything. Log 10 to x or log x is same. ठीक है, is same. ये लोग लिखते नहीं है 10. Rather understood is that it's a common logarithm. And whenever ln is written, you have to understood that the base is e. ठीक है. Example of logarithmic function f of x is ln x minus 2. That means what? That it is a log function of base e. ठीक है. G of x is equal to log 2 to x plus 5 minus 2. ठीक है. H of x is equal to log x etc. These are the example of logarithmic. ठीक है, as I told you, the domain is the set of all positive real number. ठीक है, log is only defined for all the positive real number, that is 0 to infinity. Domain of log function this, and log functions, the range of any log function is set of all the real, as I told you. Then log of any real function, so the output of a log function can be any real number. ठीक है. So the graph, there will be two different graph. As in case of exponential function, we saw two different graph, right? Yes or no? In terms of if the b, let's say b to the power x का graph कैसे होगा? b अगर greater than 1, how it will look like? It will look like this, right? ऐसे जा जाएगा. Yes or no? If b to the power x, if where b greater than 1, ठीक है. Similarly, the log function, a log graph will be, if b greater than 0, the graph will look like this. log 1 का वैल्यू 0 होता है ना, log 1 का वैल्यू कितना आएगा? any base होगा 1 का वैल्यू. You will ask yourself, b to the power what will be 1? 0. b to the power 0 will be 1. I told you na, if I ask you log 2 8, what will be the answer? So 2 to the power 3 is 8, the answer is 3. ठीक है. So similarly, if for any base b, if I ask you log 1 to base b, you ask yourself what the power should be raised for b, so that we will get 0. So b to the power 0 is, sorry, we will get 1. So b to the power 0 is 1. ठीक है. So this is done. So now this is basically the reflection about the line y is equal. Okay. In the inverse function, we will see in detail y is equal to x line. This is y is equal to x line. It will be a mirror of it. So it b to the power x, b greater than 0, and it will be mirror image of it. So this is a log function, or graph of log function when b greater than 1, and you can again see that the exponential function, right, where b is less than 1, 0 to 1 के बीच में जब बेस था, b to the power x का ग्राफ कैसा था? कुछ ऐसा था ना? Yes or no? जैसा था. ठीक है. This is b to the power x. So you can see that again the reflection of y is equal to x वाला part, sorry, y is equal to x वाला line. ठीक है. This is the y वाला x वाला line, because this part is reflected to this part and this part is reflected to this part. ठीक है. So this is all about the graph of log function. You can see that always 1, 0 is here. 1, 0, because log of 1 value is 0. Okay, and log base to base, it will be 1, because b to the power b, what the power b should be raised to get b? 1. So log base and the value is the same, the output will always going to be 1. Okay, that's all about the graph of log function, because I hope you have known something about it. थोड़ा बहुत तो जानते होंगे 11th में. ठीक है, मैं क्विकली रिकॉल करा रहा हूँ, अभी तक भी बेसिक ही चल रहा है, सो दैट यू कैन अंडरस्टैंड द थिंग्स अपकमिंग, जो भी अभी लिमिट्स आएगा कैलकुलस में. पूरे जो नेक्स्ट 2-3 मंथ्स हम पूरे कैलकुलस पढ़ेंगे, तो ऐसी ही फंक्शंस की डीलिंग होगी, सो दैट यू विल हैव अ वेरी गुड अंडरस्टैंडिंग ऑन इट. ठीक है. So now certain rules on logarithm, that is form rule, means if there are nothing is mentioned, means you can take any base here. For any base it will work. For any base, okay. For any base I am writing. It may be natural logarithmic or any maybe special logarithm. Any base of base 10 or base e, it will work. Okay. Log AB, if they're a product of two things, it can split into sum of 2, that is log A plus log B. If log A by B is here, it will be log A minus log B, the product rule. Okay. So log A by B is equal to log A minus log B. Okay. Now that is equal to log B. You got it, right? Log A by B. So if I write is the log x by y is here. So what we will do, we can write for any base, it will be log x minus log y. Okay. So now the third one, this is the second one. The first one is that log of xy is here. So you will write it as log x plus log y. Okay. The sum of log. Where log x plus log y can combine to log y. Next is that change of base rule. What is that? Suppose you have a log x to y. Okay. So for any base b, you can write log b to y divided by log b, like this. The same thing, right? It has proof, any standard book will get, but here we don't have that much time to write all this. And the fourth one is, so the very important in the derivative chapter, you are going to cover all those things again. Again, in NCERT, you can see the chapter number 5. If you open the derivative of exponential function and log function, there only you will see the graph of log, exponential functions, all the rules. Okay. Now you are feeling useless right now. It is in the board syllabus as well. ठीक है, आपके बोर्ड के सिलेबस में एनसीईआरटी 12th मैथ का चैप्टर नंबर 5 उठाओ, वहां पे भी है ऐसा. ठीक है. सो नाउ द लॉगरिथमिक प्रॉपर्टीज ऑफ लॉग for any base b, let a to the power x, this x will come into this side and reverse as well, log x. ठीक है, या ऐसे लिखा है तो you can do in that direction also, ये भी कर सकते. ठीक है, as I told you, log 1 to base x will be base, so that will be 0. ठीक है. And log a to a will be 1, and if log x is equal to log y, you can cancel log. Okay, and that will, you can write x is equal to y, or if something like x is equal to y is written, you can use log both the sides. Okay, so far we have done the log function. Next is moving to the modulus function. This is one of the important function of yours, right? Highly used function. ठीक है. The function if R2 are defined by f of x is equal to this, called modulus function or absolute value function. ठीक है. Modulus function में क्या हो जाता है? Basically, whatever you take, suppose if you take positive number, then it will be x. So that means if x is positive, any x can be any real number. So the output will be x only. Okay, if I take 5, we'll get the output as 5. If I take 6, I'll get the output as 6. But if I take any negative number, let's say -5, the output will be -x. That will be minus of -5, it will be again 5. You got it? You can see that f of x is equal to x, where x is greater than equal to 0. Suppose I choose 0, there will be 0. Root 2 output क्या होगा? root 2. If x is -5, then in that case what will happen? If x is negative, then it will be, I have to write as -x. So minus of -5, that is 5. Okay. So every time, so if it is positive, then it is getting giving you positive. But if it is negative, then also it is also giving you negative. So giving you positive. That means for any real r, the range of this will be always going to be non-negative, because for 0 it will be 0, for -5 it will be 5, for -100 it will be 100. Again, for 100 it is 100, but for any negative number also it is positive. So the range will be 0 to infinity. Okay. So modulus function, domain is r, range is this. The graph will look like this. For 0 it is 0, for 2 it is what? 2, for 4 it will be 4. But what about -2? -2 it will be 2 only. So for -4 it will be 4 only. You can see that the graph will be y is equal to x, this part, and this will be y is equal to -6. Please do remember all those things. Whatever I am telling you is very useful in upcoming classes. This branch is actually y is equal to x, and this branch is y is equal to -6. That means if you choose any negative number, this branch will make you positive. If I take x is equal to -3, what will happen? Y is equal to minus of -3, that is 3. Okay. I hope this is clear. Next is Signum function. Signum function is something like that. If x is positive, the value will be 1. X is 0, the value will be 0. If input function is less than 0, then it will be -1. Means it's simple. If this is a function, it can take any real value, no issues. But if you put some positive input, then you will get output as 1. And if you put 0, it will get 0. And if you put a negative number, then you will end up with -1. So domain can be any real number, but range should be that's these 3 numbers only, not other than that. The graph will look like this. For 0, it will be 0. See, Okay. This is a hollow circle. But if you take any positive number, let's say 0.1, then it will again jump into 1. So for any other values, it will be 1 only. Similarly, if I choose like 0.001, I'll get the value will be f of x value will be 1. If I choose minus 0.001, then what will happen? F of x value will be, for any small negative number, it will be minus 1. Okay. So the graph will jump into this side. So graph will look like this. यहाँ पे जो blue दिख रहा है ना, यहाँ पे भी एक blue dotted आएगा. So 0 के time it is 0. ठीक है. 0 के time it is 0. Then this graph completes. 0 के time 0. बाकी यहाँ पे hollow circle because this point belongs to this arrow. ठीक है. Now the value of signum x square plus root 3 कितना आएगा बताओ? Value of signum x square plus, इस signum function को xgnx लिखते हैं, इसका नाम ऐसे है. ठीक है. sgnx जैसे लिखते हैं हम f of x, मतलब फंक्शन का नेम ये है. सिमिलरली सिग्नम फंक्शन मतलब sgnx, जैसे साइन फंक्शन को लिखते हैं sinx, मतलब ये उसका नाम है साइन. देन इट्स वेरिएबल, मैं लिखूंगा साइन थीटा, मतलब ये उसका साइन का नाम है, ये थीटा उसका एंगल. ठीक है. मतलब इसका इनपुट थीटा है. दिस इज हिज नेम cos थीटा, मतलब cos इज अ फंक्शन, दिस इज द नेम ऑफ द फंक्शन. सिमिलरली log x लिखते हैं मतलब logarithmic function with the variable x or input as x. Similarly signum function sgnx, sgn stand for signum function and this is the input. ठीक है. So I have written signum of something, just like हम लिखते हैं ना sin x theta plus pi by 2. ठीक है. वैसी तरह लिखा गया signum x square plus root 3. You can see that this will be a positive number. Yes or no? X square means what? Any non-negative number. Okay, always going to be greater than 0 plus root 3. So this is always going to be positive. Yes or no? Positive हो जाएगा. So that means क्या हो जाएगा? Answer 1 है. Again, the value of signum e to the power x plus 1. See, exponential function range is 0 to infinity. It is always positive. Plus 1, it is again positive. So the output will be 1. And the value of signum function mod x minus root 3. Mod x is what? Mod x means x varies from minus 2 to 2. If x belongs to minus 2 to 2, if you take mod of it, you will get what? 0 to 2. Yes or no? And if you take a negative number mod, you will get positive. So minimum value will be 0 and maximum will be 2. So mod x will 0 to 2. So 0 to 2 number minus 3. It will be negative. Yes or no? Yes or no? Any number between 0 to 2 minus 3, it will be negative. So that means it will be minus. Okay. I hope this is clear. This is all about for today's class. Okay. It's been now 10:58. So we are closing the class here, and in next class, like in upcoming class, we'll be finishing the standard function and then go for the type of functions, that is on to bijective and everything. So next we'll be covering like almost next 30-40% of the entire functions chapter. Okay. So far we have covered a lot of basics now. Like we saw the functions, then representations, then vertical line, then domain range of different functions, and now also we saw all the standard functions. There are only two functions, that is greatest integer function and fractional part of function. Once that is done, then you can jump into algebra functions and then the various type of. Okay, got it? So I hope you revise all these things and keep in your memories whatever you taught in last two classes, like on Saturday evening and today. So if you remember all those things, then it will be very much helpful to grab the upcoming things, right? Otherwise, it will be very difficult for you to understand or to know it, right? In order to understand this concept, you have some fundamental background knowledge, and that we are providing. This week, I provided all the background knowledge in order to understand functions, right? So that you can solve some very good numerical. Okay then, thank you for your time, guys. Have a good day. Take care. Bye-bye.